So the purpose of this video is to demonstrate that simple harmonic motion exhibits sinusoidal motion. And what do we mean by this? Well, we already know that when we look at an object in simple harmonic motion, or a simple harmonic oscillator like a mass spring system, we know that the position of a function of time can be summarized by the formula x is equal to a cosine 2 pi t divided by the period. Now, what does this mean? Just a reminder. That means that the position at any time is dependent upon the amplitude of the mass spring system and the period of the mass spring system. Now, you notice that this function contains a cosine. Well, the cosine is related to sine. And if we were to plot any sort of cosine or sine function, we would end up getting a wave, a sinusoidal wave. So what I've done is I've set up a mass spring system here, or spring mass system. And we're going to set this in motion. And I've attached a marker to the bottom of the mass, and the marker is pressing against the whiteboard. So let's pull this down to negative a and release it. Now we see that, in fact, this is moving up and down. That's simple harmonic motion. We're familiar with that already. But what I have drawn on the whiteboard is a y-axis, the y-axis representing the position. So I've actually denoted it as x. And the horizontal axis is denoted as time. So the way I'm going to show you time here is I'm going to move the board towards the left of the screen, and we'll see what happens. So I tried to move the board at a constant speed, and what we see is the wave goes up, it goes down, it goes up, it goes down. It moves in the positive A direction and then in the negative A direction. And the result is a sine wave pattern. So as you can see, simple harmonic motion exhibits a sinusoidal pattern.